Alright guys, day 12 of the 100 Days of LeetCode. Today we're finishing up with the binary trees. We're going to be doing the level order of traversal, but if you haven't seen the first three binary tree videos, first on in-order traversal, post-order traversal, excuse me, and pre-order traversal, check them out. They're linked in the description. Yeah, without further ado, let's go right to the iPad. So we're just going to start off by constructing that binary tree that we've been using this entire time. That's actually 23. Over here we have 9, we have 14. You know what? This is bothering me. Let's fix that so we can actually read it. 18, 27, and that's our tree. Okay, so what we do for the level order traversal, which is also called breadth first search, by the way, but for the sake of this video, I'm just going to be calling it level order traversal, as they do on the LeetCode problem. We're going to traverse it one level at a time. So our first level is going to be the root. Let's do this in red, just so it's not confusing. You don't get confused with the nodes. Okay, so that's going to be our first level. The children of the root are going to be our second level. And then the children of the root, they'll be our third level. And we could go on and on and on and on. And for this particular LeetCode problem, all we're going to be doing is we're just going to be creating a list for each of the levels. And then we're going to be inserting them into what I'm going to be calling the master list. So it's a list of lists. And when we're all done, we should have a master list looking like this. So, how do we write the code? Let's find out. Alright guys, so the first thing we're going to do is we're going to create a list of integers. We're going to call it master list, then we're going to say equals new array list of integer. And we need, in this case, to have a check, because if we don't, we'd run into problems inside the loop that we're about to write. If there's a null tree node in the queue that we're about to create, we'd end up getting an error. So if the root is null, we're simply going to return the empty master list at this point. Now what we're going to do is we're going to create a queue, if I could spell queue, and it's going to be a queue of tree nodes, and we're just going to call it queue, and it's just going to be a linked list. And the first thing we're going to do is we're going to offer the root to the queue. Now, the difference between offer and add is that if the offer fails, it will simply return false, as opposed to the add, which will throw an exception. So in this case, we shouldn't get a situation where this fails, because we're not putting a size limit on our queue. But in other situations, it's better to use offer, and then you can just use that Boolean value for whatever you need to use it for. So now what we do is we just create a while loop, and this is going to keep going while the queue is not empty. And inside this loop, we're going to just say the current size is equal to the queue.size. I'll explain why we need to do this in a second. And in here, we're going to create a list of integers, and we're just going to call that new level equals new array list of integers. Okay, so now we create a for loop, and the reason why above we had to initialize that variable is because we had to ensure that we're only doing this loop a set number of times, right? And if we just used q.size right here, what would be happening is that this q.size number would be sort of changing depending on what we do inside of this loop. And it's much better, in fact, it's way better to have a fixed number in the iteration. So that's why we save that right at the top of the while loop. And we're just going to create a current tree node, and it's going to be q.poll. So this is similar to the pop. And what we do now is we just say new level dot add the value of current. And now we check if cur.left not equal null, then q.offer cur.left. Oops. If cur.right not equal null, we do q.offer cur.right. So now we're essentially adding the left and the right children of whatever node we're at to the queue, so that they'll be operated on in the next iteration of the while loop, not of this loop. Okay, and now all that's left is for us to return our master list. And that should work. Oh, yeah, we forgot one more thing. Master list dot add new level. We need that at the end of every iteration of the while loop. There we go. All right, guys. So that was day 12 of the 100 Days of LeetCode. If you've been enjoying these videos, I'd appreciate a like and subscribe. It'd mean a lot to me. Yeah, we're going to keep it going. We got another 88 days to go. It's exciting. Let's do it.